Welcome dear students. In today's class, we will be focusing on one important formula and the formula is written out here. Okay, so you can note this in your formula book. Now let's see how to use this formula. You can take any problem here. So I'll do number 2 for you. Number 1 you do it by yourself. It's same. Okay, so let me start with number 2. So what you need to show is the value of this is equals to 2. So let's evaluate this and check whether we get 2 or not. So we have 1 by log 36 as at the base 8 plus 1 by log 36 at the base 9 plus you have 1 by log 36 at the base 18. Alright, so basically you see here we have 36, 36, 36. Okay, so they are argument but the base are different. So you have to make your base equal. You have to keep that in mind. Okay, so you have to make your base equal. Here we have 8, 9 and 18. You have to make them equal. So base will be equal if and only if these two can be exchanged. So if 36 comes here, this 36 comes here and this 36 also comes here, then only the base becomes same. So that can be done using this formula. You see here carefully, here a is in the argument. Okay, sorry, this is a, okay, not b, and this is gonna be b. This is the formula. Now if you see here, a is in the argument but here the a has gone to the base. Okay, so this is called exchange of base formula. This formula is called exchange of base formula. So let's do that then. So if we exchange, then it becomes the reciprocal. Okay, keep that in mind. So we have log, so this 36 comes to the base, so 36, and this 8 goes out here. Similarly, this becomes log 9 at the base 36 and this becomes log 18 at the base 36. Okay, so now since the bases are same and we have in the middle plus sign, so we apply product rule here. Okay, so we have log 36, in the middle we have plus, so we will multiply 8, 9 and 18 together. You can do it. 8, 9 and 18, they will be multiplied. Okay, so we have log 36. So let's see how much is this. Okay, so you have 8 9s are 72. 72 into 18. So see here carefully, we have to write this in 8 into 9 into 18 is, this is how much? This is 72. Now you know that 72 can be written as 36 into 2. Now you might be wondering, why am I writing 36? Because we have 36 in the base as well. So now we have 2 and 18. So when you multiply 2 and 18, then also you get 36. So basically 8 into 9 into 18 is nothing but 36 into 36, which is 36 square. So I'll write this as 36 square. Okay, you can do this. You can write this in your notebook. So now you know that this 2 comes front, the power comes from, so it comes front. So this becomes 2 log 36 at the base 36. Now you know that if the base and argument they are equal, the value of the logarithm becomes 1. So it is 2 into 1, which is equals to 2. So that's what we need to prove here. Okay, so you may pause the video and note down your solution. Let's do this question. Okay, so now here also you have ABC, ABC and ABC here in the argument. So we will take them to the base. So we have number 1, 1 by log ABC at the base A plus 1 by log ABC at the base B plus 1 by log ABC at the base C. So we will do exchange of base. So when the bases are changed, you know that it becomes a reciprocal. So it is log ABC at the base. Okay, this is the base, and you will write in the argument A, plus similarly this is going to be log ABC plus we have log C at the base ABC. Now since the bases are same, again I can apply, once the bases are equal and since there is plus in the middle, I can apply again product rule. So we have log ABC. So A into B into C is ABC. Now you see the base and the argument, they are equal. So automatically the value of this is going to be 1. I hope the sum is clear to you. Now let's do number 2 also. So we need to prove that this is equals to this much. Okay, so we have, let me start with the left hand side. So we have log A at the base B into log B at the base C into log C at the base D. So let's simplify this. So now we will keep these as it is. Let's see how much is this gonna be. Okay, so we have log B at the base A. Now see, B is in the base, so I'll try to bring this B in the base. So for that I'll use again the same exchange of base formula. So it becomes log C at the base B into we have log C at the base D. So this in turn can be written as, so I'll do the rest of the work here. So we have, so this part, can I write this as log A at the base B by log C at the base B? Yes. So into we have log C at the base D. Okay. Now all of you know this is called change of base formula. You might have written. So if you remove B and B, this A is on the numerator, so this comes in the argument. C is in the denominator, so this goes in the base. So basically this is equals to log A at the argument and C at the base. Keep that in mind. So if you have forgotten, I'll write it down here. So we have log at the A at the base B is equals to, A is on the upper position, so keep it at numerator. B is in the lower position, so keep it at denominator, and now you can write any base you want. So I write C here. Okay, so same thing is happening here. So this is equals to this. So similarly this is going to be equals to this. Now at the same time you see here, what is the base? C, but here C is in the argument, so I'll make it in the base. So it becomes log D at the base C. Now again, can I write this as log A at the base C divided by log C at the base D? Yes. So again we will apply the same formula. You see, A is in the upper position, D is in the lower position, and the bases are same. So that means it will be equals to log A at the base D. A is in the upper position, D is in the lower position, and that's what we need to prove. Okay. So this is the way we need to prove it. So you may pause the video and note down the solution. So this is going to be the last question from your exercise, or rather from the chapter. So I'll take any one. Okay, so the next sum is similar to what we do right now. So I'll do number 1. Number 2, you do it by yourself. Okay, so number 1, it is given that, so we need to find what is the value of x. Solve for x means we need to find what is the value of x. So what is given to us is log x at the base 3 plus log x at the base 9 plus log x at the base 81 is equals to 7 by 4. See, we have different bases. We'll try to make them equal. So that can be done only if we use exchange of bases. So we can exchange these two. So this becomes 1 by log 3 at the base x plus this becomes 1 by log 9 at the base x plus similarly 1 by log 81 at the base x is equals to 7 by 4. So here we have 1 by log 3 at the base x plus 1 by log. Now we have 9. Can I write 9 as 3 square? Very much. So similarly this 81 can be written as 3 to the power 4 is equals to, we have 7 by 4. So we will apply the power law in the second and the third. So this power comes from, so it is 1 by 2 log 3 at the base x plus similarly 1 by 4 log 3 at the base x is equals to, we have 7 by 4. Okay, so yeah, you see you have log 3 and log 3 common everywhere. So we will take log 3 common. So what do you get? 1 by log 3 at the base x is common. So if this is gone, then here 1 is left. If this is gone, then here 1 by 2 is left. And at the last, if this is gone, 1 by 4 is left. Is equals to, we have 7 by 4. So 1 by log 3 at the base x. So let's take the LCM here. LCM is 4. So it's going to be 4 plus 2 plus 1 is equals to 7 by 4. Let me do the rest of the work here. So here we have 1 by log 3 at the base x into, so when you simplify this, the numerator is 7 by 4 is equals to, we have 7 by 4. Okay, so you can directly cancel here. So here we have now 1. Let's do the cross multiplication. This into 1 is log 3 at the base x is equals to, you have 1. Okay, and then see, you can apply exponential form also, or else what you can do is you can write this as log x at the base x. So you see these two can be removed. So what is this? This gives you 3 is equals to x. So therefore what is the value of x? The value of x is 3 in this case. Okay, so you may pause the video and note down your solution, and you do this one by yourself in the same way. That's all for today. Thank you very much.